In this problem, you will write a rule to describe a nonlinear function. The ordered pairs 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32 represent a function. What is a rule that represents this function? Make a table to organize the x and y values. Write each pair of coordinates in a row of the table. For each row of the table, identify rules that produce the given y value when you substitute the x value. Then look for a pattern in the y values. How can you use reasoning to write a rule? You can solve a simpler problem by writing a rule based on the first one or two rows of the table. Then see if the rule works for the other rows. Look at the first row. What rule produces 2, given an x value of 1? The rules y equals 2 times x, y equals x plus 1, and y equals 2 to the x power work for the ordered pair 1, 2. Now find which of these rules works for the other rows of the table. Look at the next row of the table. The rule y equals x plus 1 does not work for the pair 2, 4 in the second row, so that is not the rule. The rule y equals 2 times x works for the pair 2, 4, but not for the pair 3, 8 in the third row, so that is also not the rule. But the rule y equals 2 to the x power works for all three ordered pairs. Test this rule in a few rows. 8 equals 2 times 2 times 2, which is 2 times itself 3 times. And 16 equals 2 times 2 times 2 times 2, which is 2 times itself 4 times. The pattern of the y values matches the pattern 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, and 2 to the fifth power. So y is always 2 to the x power. So this function can be represented by the rule y equals 2 to the x power.